Hello guys, I'm Ajman and today I'll be explaining the paper 3 mathematics of A level. So for our first question, we have to find the coefficient of x cube in the expansion of this term in ascending powers of x. Okay. So firstly, in order to find the coefficient of x cube, we need to first expand this. All right, and then we can multiply with this since this part is much more complicated. So we first did that here. We expanded this, and how much should we expand? That's the first question. But first, before that, we need to make sure that the leftmost power is 1 because it makes things much simpler. So we factor out 4 from both of them, and while factoring out 4, since if we want to factor out 4, let's try that over here. 4 it becomes 1 plus, and this becomes 6 by 4 or 3 by 2 x, and then this entire thing has a power of minus 1 by 2. So when we take this out, this will get this power also. That's why we have 4 to the power minus half here, which becomes half. So we have this, and then we expand this part, and then later we multiply it with half. Okay, so let us do that. So over here we expanded this in ascending powers. The thing is, see this term, we need x cube, right? A coefficient of x cube. Over here we have a term with no x, so when we multiply this with x cube, we get the term that's the coefficient of x cube. And for this, since we already has an x, we need expansion of x square. We multiply that with x square, and then we get then we get x cube. So these two are the only ways we can get a coefficient of x cube, because everything else has like power 1, 0, or whatever, and those things will multiply here with here to get x cube. So these are the only two we need, x square and x cube. So we expand only these two parts, and then we multiply this with half, so we get this. So we just use the binomial formula here, expanded and for only for these two, and then we use this for this. And the formula we use is this NC. So over NCR, and the first term, let's just write x here, x to the power n minus r into let's write y here, y to the power r. So over here n is minus half, and c is, since we are doing for this, our c is 2, and x is just simply 1, and n minus 1 is, so n minus r, so minus half minus 2, and then into y, which is 3x by 2 to the power 2. So yeah, like that we found both of these terms. You just simply using this formula, and then multiply this with half, and we get this, and then we multiply this with this term over here. So over here we multiply 2 with this, so that will give us a coefficient of x cube, and this with this. So that's what we do here, and then we just simply add, and we get the coefficient of x cube. So this next question, we have to prove the identity that this and this are equal. So the way we do this, we have two options. Since it's tan, we can use the tan 2 theta formula, or we can go the sine by cos route. So both seems valid, and then a lot of people tried this, but then these steps are way too long. A lot of people found too many steps and led nowhere, but it is possible to solve this way, but it's not very efficient. So if you tried it, or you try out this two method, and firstly you see that this is not going anywhere, taking way too long to get to where we need to go, and this method easily goes there. So let us see. Over here we simply break this down by sine by cos, and this is sine by cos, then take and then get the denominator together, so sine. So this is what we do here, and then we notice that this is the formula for sine. This is one of the angle formulas from the formula sheet. So that which one is sine A plus B. So that formula. So we just simply see that from the formula sheet and convert it to this version. And then sine 2 theta minus theta is sine theta, and then sine by cos, right? So sine by cos is tan, which is going there. So sine by cos we tan, and then we have 1 by cos 2 theta, and that gives us 6 2 theta. So again, we are asked to integrate this, but we cannot really integrate this. So we convert this into this form. Since this is this is what we need to do. Makes it simpler. So we just simply convert it to this, and then we simply integrate. Tan 2 theta's integration is ln cos 2 theta, and then we divide by minus half because of the 2, and tan theta again is simply ln cos. And then we simply substitute these values or subtract, and we get the final answer. So in this question, so we have a biological culture that is growing in a controlled environment at times. So at time t days, the mass of the culture is x grams. So the x is the grams, and it dependent on t, this is the time. So the rate of growth is modeled by this differential equation. where k is a positive constant and is given that. So we know these two conditions, when t equals to 0 and t equals to 1, and then we need to solve the differential equation and show that k equals to 3. So very straightforward. So over here we have dx by dt. Um, we simply solve this the normal way. So we simply get the x variable together and the t variables together. So we have dx by dt, right? So we get the t's into one side. So that's what we do. So if I show it here, so dt we can simply take here, and this term, this part, since it's x related to x, we take the entire thing here, or we can keep the k here also, because k, it doesn't really matter, k is just a constant. So we just take the x plus 9 here, which is what we do here. We do the x plus 9 to the left with x, with dx, and the 3t plus and the dt to this side. So this is what it becomes, and then we integrate separately. So this becomes ln x plus 3, and this becomes 3t plus 2, and then both of them will have a plus c. So we can just combine them and give a plus c here. So that's what we do, and then we apply these two conditions. So we apply the first condition here and get this formula, get this equation, in the second formula, and then we get this second condition and get this equation. Then we need to, since we have two variables now, k and c, we are looking for k first. We don't need the c, so we can just subtract them, and this will eliminate the c. So we subtract, we eliminate the c, and then we get this. And when we solve the equation, there's only one variable k. When you solve this, we get k equals to 3. So that's it. So for the next sum, we need to find the value of t when the mass of the culture is 100 grams. So over this time, we know the value of x. We know that x is 100 grams, and we need to find the value of t. Okay, so we already have the equation. We already know the equation from here. This equation basically. So we can use any of them. So let's just say we use this one. Oh no, sorry, we have to use this one, because this one over here we applied the conditions already. We didn't apply them here, so we use this one. Okay, so we know the k value, so let us just convert this into normal problem. So firstly, oh, there's another extra variable c, right? We don't know the value of c. We need to find out the c. Last equation, we didn't find out the value of c because it doesn't need it. We could just find k directly. Since now we know the k, we can find out the c first, and then we can use this. So let us do that. So c. Okay, so we have this equation. We simply substitute the k value. So we have ln 10 equals to k by 2 is simply 3 by 3, which is, so we are left with ln 2 plus c. We can take ln 2 to the left, so ln 10 minus ln 2 equals to c, and then this becomes ln 5 equals to c. So c is ln 5, so which is given here, ln 5. So now we can use this equation. So we can simply use this equation. So that's what they did, ln x plus 9 and then 3, and then 3t plus 10, which is there, and then they just apply the c and the k also. And now we can solve this. So we can combine them. We can combine these two lns. This is addition. We can multiply 5 with 3t plus 2. This is what we did, and since both of them have ln, they took out the ln. So we have x plus 9 and 5t plus 2. Then since we already know x is 100, so they replace the x with 100. So with this, so we have 100 plus 9, which is 109, equals to 5 to the 15 plus 10. And then they simply solve this equation and got the value of t. So in this question, we have a diagram with where A is the midpoint of a semicircle with center O and radius R. So it's also given in the diagram with radius R, and the circular arc with center A meets the semicircle at B and C. So this is another circular arc, and the angle OAB. So OAB is equal to x, and the area of the shaded region. So the shaded region is equals to 3 quarters is equal to 3 quarters of the area of the semicircle. So the shaded region and semicircle. All right. So our first question is, use triangle OAB to show that AB is equals to 2r cos x. So we want the length of AB. So over here, what do? We can convert this. Since we need to use a triangle OAB, so let us draw it first. So we have triangle OAB, and we're trying to find AB. Can we use anything? We have only this. We don't know AB, or we also know the R and this. So we have two directions over here. So maybe we can use the sine rule to find this, or yeah, but then we don't know R or X. So, and over here we have cos here. So another thing we could do is we can divide this triangle into two parts. So that way we have two right angle triangles. So this and this. So we can use this. So since we know this is isosceles, like this and this are equal, this has to be isosceles. So this is also X. So we can use this to find the value of half of this, and then double it. So let us see, we can use SOHCAHTOA, right? So we have know this and this, so we can find out this. So R, um, so let's see, cos x, right? Adjacent by hypotenuse. So we can just use, so this is hypotenuse, this is adjacent. So cos x is equals to adjacent, which is AB by 2 by hypotenuse, which is R. So we can rearrange this now. We can make R the subject. Sorry, we need to make AB the subject. So we can just rearrange this to R cos x equals to AB. So yeah, that's it. So this is the what they want. We need the value of AB, and AB is equal to 2R cos x. Okay, so the next question, it says hence show that x is equals to this. So we had another clue, right? We remember we had the clue that this shaded region is 3/4 the area of the semicircle. So definitely that's what we need to use. So that's it. This is what they did here. We already know AB, right? So AB is the radius of this circle. So we know how, what the formula we use is half r squared theta, where r square is the AB, so half r square, so 2r x square, and then theta is x 2x, because this we need this entire thing, so 2x is theta, and this is equals to 3/4 of the circle. So formula of the circle is half. So normally the area of a circle is pi r square, right? And then we do it half because it's semicircle, and then we do 3/4 because this we are told that the shaded region is 3/4 of the area of the semicircle. So that's what we do over here, and then we rearrange all this. So we make x the subject. So over here we know that we keep the x here because we know that we will have to inverse at the end, right? So we keep the cos x and take everything to the right. So we take 2x to the and everything to the right. So yeah, 8x. So this becomes 8x, and we take it to the right. So this becomes 3 pi by 32x. Then we square root, and then we inverse cos, and we get what we are looking for. So lastly, this one is very straightforward. So over here, we need to verify by consider that x lies between 0.5 and 1. So how do we do this? We simply create a function g of x, and then we set it equals to, we subtract this from this. So cos x minus x. So if it's between 0.5 and 1, if we apply them, we will get numbers that go from first is positive and then is negative, or the vice versa, whichever direction we go. Both of them work, since like basically this is the graph, the answer will is here, let's say, and then since we're approximating, we will be here or here. So the lower range will give this answer and the upper range will give this answer, and then since there one will be negative and other will be positive, we will know that the answer must be in between this. So that's exactly what we do here. We put the 0.5 and then over here, and then we get 0.196. So this version, this one, the 0.5 would be the upper range, and then the we put 1 and we get minus something, so that's a negative range. So that means if it's between, so that means the answer must be between these two, right? Since it goes from positive to negative, so the answer must be between 0.1 and 1. So that's why we prove that the root exists in this interval. Now we do use the iterative formula. This is very easy. So what we do, we simply take a value in this range from 1 to 0.5, and then input into x, and then whatever we get, we input it again, and then we keep on doing this until we get something that's stable. Like over here, we're seeing that we need the answer in 3 decimal places, and we're seeing that the answer isn't changing. So we just end it here and give 0.996. Also, yeah, that's it. And we have to give the iteration of each of the iteration not to 5 decimal places. So we do this here. So we stop when we see it's not changing much. So over here we have a partial fraction question. So we have this this function, and then we need to express this in partial fraction. So first we need to figure out how the form of it will be. So since these are the denominators, it will be 2x minus 1 will be one of them, and since this part is squared, one will be x plus 2 and the second one will be x plus 2 squared. We need to have both of them. So, and then what we do, we multiply both sides by 2x minus 1 and x plus 2 square. That way this entire thing goes away, and for every term like some parts of it go away. So over here for a, this part will be gone, and we'll have x plus 2 whole square, and then x plus 2 will be gone here, and we'll have 2x minus 1 and x plus 2, and for this entire thing will go, and we have 2x minus 1. And then we simply so over here Then we can find out the values of a, b, and c. So over here, x equals to 0.5 implies. Okay, so over here, why do we put x equals 0.5? We know that if you put x equals to 0.5, this part will become 0. So if we do that, this term and this term vanishes, and we are only left with this term. So that's why we set x to 0.5, and we get this. If we do that, we get this part becomes 25, and all this part vanishes, and we're left with this just. And x plus 2.5, 0.5 is 2.5 whole square into a. Using this, we can find out the value of a. And then next, we do the same trick again. This time we use x equals to minus 2. That way, this term vanishes and this term vanishes, and we are left with only the c term, and this term becomes minus 15, and we get the value of c using this equation. Now since we have both, since we cannot do this for here, because if we set this for this part for b, we could set this to 0, but then we could set this to 0, but there's no point, right? This term is already here, so b will vanish or x will vanish. There isn't any way to vanish both of them except this, but it's fine since we know the value of a and c already. So what did they do here? We have the coefficient of x square. So over here the method used is that we have, so they take the coefficient of x square. So over here, if we expand this, we check, only check the coefficient of x square. So over here there is no x square, right? So the coefficient of x square on the left part is 0, and over here if we expand, we will have x square here, right? So a into x square, so that's the coefficient of x square is a. And over here we have x into 2x. That's the only way you can get x square. So 2x square b. So the coefficient of x square is over here 2b. So there's no coefficient of x square here, so 0 is equals to a plus 2b. So that's one equation. And then from this, we already know a value of a, so a is 4 plus 2b, and therefore b is equals to minus 2. So that's one way. Another way we could do is we could apply the values of a and c into this equation, and then compare. So let us do that. So 16x plus 7, we put the value of 4x plus 2 whole square plus b 2x minus 1 plus x plus 2 plus c is 3. So 3 2x minus 1. So over here we simply open the brackets now. So 16x plus 7 equals to 4x square plus this will be 4, so 4 for the 16x plus 2 to the 4 for the 16 plus b, we have 2x square plus 4x minus x, so plus 3x minus 2, then plus 6x minus 3. Then we have 6x plus 7 is equals to, so we're just breaking everything down over here. So we have 4x square. Okay, it's already broken down really. So now we can just compare coefficients. So for b, we have let's just look for x square first. So we have x square here, and there's no x square term here. So there's no coefficient of x square in the left. X square's coefficient is 4 here. And for this part, we have plus 2b. Then we see, so same thing, but we're expanding the whole thing this time. Then we can find the value of v. We'll do other ways also. We'll see the coefficient of x. So we have 16 equals to 16 plus 3b plus 6. So these two cut each other out. Then minus 6 by 3 is b equals to again minus 2. So same thing. We could also do it with this term. Plus 7 is equals to 16. 7 is equals to 16 minus 2b minus 3. So again this becomes 13. 7 minus 13, that's minus 6, and then divided by 2b, again we have the same thing, minus 2b. So okay, by the way, this was minus 16, I think. This one 16. Wait, we got 2 here. Let's just do this part again. So we have 7 is equals to 16 minus 2b minus 3. So this becomes 13. And if we subtract 13 from 7, we get minus 6 equals to minus 2b. So we get a different answer here. B would be 3. This is not supposed to be like that, so let us see where it went wrong. We have 2 to the 4, 4 fours are 16. We had minus 2 here, so it's minus 2, and this part we have minus 3. Oh, so this term is actually 17. This is way you can check if you made any mistakes. So this one should have been 17. So 17. So this part, so now we can do this again. 17 minus 13, that's 4, equals to minus 2b, and b is equals to minus 2. Again, same thing. Just we have like, we're just comparing coefficient to figure it out. And this part, just simply um, compare x squared coefficient directly. So over here we have two vectors. Points A and B have position vectors, this and this, and the line L has this equation. Okay, show that L and the line passing through AB are skew, so they don't meet each other, so they go around each other. So something like they have no point of intersection. So how do we show this? First we find out the line of AB. So the line AB, we simply take one of the points over here. We took these points, and then we got the direction vector. How do we get the direction vector? We simply subtracted them from one from the other. So we subtracted this from this, and then we get the direction vector, and then we found another vector equation line. And our line equations we just convert to this form, and then we equate them. Since they do not we need to prove they do not meet. So let us show that what if they meet, and we prove that that is so contradiction. So let's assume they met. So we equate them. So we put 1 plus lambda. So this x point, we were equating the x point here, and then we got this equation. Then we are equating the z point. So from third, so this one's, oh sorry, these are the three equations. So we're equating each of them. So these are equating the x, equating the z, y, and equating the z. And then from this we got this equation over here, and we substitute in this equation. Basically we go from this, we simplified to this, and then we substitute this to here. We got a, using this we got a lambda value, and then this lambda putting it into this equation gives us this mu, and then we put both of these values into this equation to check. Since since if we assume they met, all these 3 points should be equal, right? So we're assuming these 2 points are equal, and then we're checking if this point is also equal or not. But we don't, it doesn't work. When we put the lambda, we get minus 9 on the left, and the mu gives 5 to the right. So these are not equal. That means it's not possible for all 3 of these points to be equal. That means the lines do not intersect, and since they're not parallel, and they're not parallel either, because their direction vectors are different, right? So this is the direction, this is the direction for this. So that means they must be skew. So yeah, that's it. So in this question, we have the diagram that shows us, this is a diagram of y sine 3x cos x, and the domain is still pi by 2, and its minimum point is m. Find the shaded region is bounded by r. So this is the shaded region and the x-axis. Okay. So by expanding sine 3x plus x and 3x minus x, show that this is equals to this. So simply we just expand. So we just do what they told us in the question. We use the formula to expand sine 3x and sine 3x minus x using the formula from the formula sheet. The formula where like sine a plus b equals to sine a cos b. So that formula in the formula sheet, and we just simply get them. So we need to so we can just work backward here. Since we're using the formula, we add these two parts. Yeah, so sine 3, so this is sine 4x, 3x plus x, so this is sine 4x, this is 3x minus x, so this is sine 2x, so which is this. And then when we add this, these two parts cut each other out, and we are left with this. So we're almost here. We just take 2 to the left. So we took 2 to the left and take this entire term to the left, basically. So this becomes half, 2 to the left becomes half, and then we get this. So yeah, that's it shown. The next part, find the exact area of the region R. Okay, so this is the region R, and to find the exact region, we also need this point. So let us find that out. We first equate this to 0. So sine 3x cos x equals to 0, and then we get the values x equals to 0, pi by 3, and pi by 2. The reason we discard pi by 2 is because it's not in the range, right? And we already know start from 0, so that's the starting point, and the only other solution that makes is pi by 3, which is less than pi by 2. So this must be this. So we only use these 2 points. So with this is basically the limit, are the limits. Then we want to integrate this. this equation, and we know it's equal to this, so it's easier to just put this here, and then we simply integrate using the formula. So we get this as subtract and we get the final answer. So over here, using the result in part A, express dy by dx in terms of cos 2x, and hence find the exponent of m. So express dy by dx in terms of cos 2x. So let's see, do you have any dy by dx? Okay, so we need to find, we need to differentiate it first. Okay, so we simply take the equation and differentiate it. And which version do we differentiate? We differentiate this version, because simpler to differentiate. We need to give the answer in cos 2x form. So since this version is already both of them are already signed, right? And if we differentiate, we'll get cos. So this is easier to just differentiate this version. So that's what we do. We differentiate this version and we get this. And then we need to, in terms of cos 2x, we need to express. So we simply use the formula from the formula sheet to convert cos 4x into this. So this is one of the cos 2x formulas. So we just simply do that, and then we can rearrange, and you will notice that this has become a quadratic if we assume that cos 2x is, let's say, z. So then we solve the quadratic and get the value of 2x. So and then we just simply divide to get x. So since we have two x's, so first one gives us this. So this is the first maxima. So these are maxima, and it's less than pi by 3. So we know this must be the maxima, since we can see it from the graph. Also, sorry, they asked for the coordinate of m, not the first maxima. So we know this is not the solution. So this is the first maxima, so not the solution. The second formula we got, since we have a plus and a minus, so the plus gives us this, and then we divide and get the second m. So this is the second. So this is less than pi by 2 but greater than pi by 3. So we know this is the minimum. So we don't have to check, because we can already see it from the diagram. We got two answers. And the first one is less than pi by 2, so it must be the maxima, and the second one is less than greater than pi by 3, less than pi by 2, so it must be the point m. So over here we have an imaginary equation. So we have this, a quadratic, and we have to solve this, giving our answer in the form x plus iy. So where x and y are real. Okay, so to solve this, we simply use the quadratic formula over here. So we get this, but this is not in the form we want. This has a square root in it, and so what do we do? So square root, as in, it's squaring the I. So that's the problem. We need the I to be alone. So what do? We find out the square root of 2i. So let us say that a plus bi is the square root of 2i. So if you square it, we get 2i. Then we expand this, a square plus minus b square. Let me just do it here again. A plus bi whole square is equals to a square minus b square. Since I square makes it minus, so I square is minus, this b square plus b square becomes minus b square, and then plus 2abi. Okay, so this should be equal to 2i. Now we just compare the term. This has a I term, but this doesn't have it. This doesn't have I term, and there are no non-I terms here. That means a square minus b square must be equal to 0. So a square equals to b square. So or a is equals to b. And so over here we also have another equation, 2ab is equals to 2. So 2 we can cut each other. So a is equals to 1 by b. Alright, so we can substitute them. So we can substitute a by b. So we get 1 by b is equals to b, or 1 is equals to b square. Therefore b square is equals to plus minus 1. And then simply if we put this here, we get a is equals to 1. Using this equation, we put plus minus a here, b here, and then we get 1. So a is equals to 1. But also we can also put the a could also be minus. Yeah, right, we have this here. A could also be minus. Since it's plus minus, that this will also be plus minus. They will always just be equal. So our two answers are that a equals to 1 and b equals to 1, or a equals to minus 1 and b equals to minus 1. So these are our two answers. So we can, let us write that. So let us write in this form. So this is plus minus 1 plus I. Yeah, basically this, and this is equals to square root of 2I. So we can simply substitute this part into here. So that's why we already have a plus minus in the front, so we just do that. So we can just substitute. So let us do that here. 1 plus minus, so over here we have plus minus 1 plus I, so we just simply replace that. So 1 plus minus 1 plus I. Okay, so this becomes, so we have two cases, one is plus and minus minus. So if we took the plus case, this becomes 1 plus 1 2 plus I, and the other, if we take it to the minus, then it's 1 minus 1 is 0, and we're left with minus I. So these are the two solutions of W. Okay, now we in the diagram. So on the diagram sketch, shade the region whose points correspond to the represent the complex number satisfying these two equations. So the first one, so over here we have basically it's a circle. Okay, so over here with center 2 and 2I, so 2 2I, so this is the center with a radius of 2 and it's less than, right? So it can be any region inside, so any, so all these regions, anything inside, but it has to satisfy more conditions. So over here it has the argument of z minus 2, so it's z minus 2, right? So it starts from here, so this argument must be greater greater than pi by 4. So this pi by 4 does it greater, so this part is out, this part we won't be counting. So it can be this region or this region, this whole thing. Also it has to be less than pi by 2, so this straight line, so we can't even count this part, then we're only left with this purple shaded region. So that's how we do this. So so over here we have to use the substitution u equals to root x to show that this is equals to this. So so simply, yeah, that's pretty straightforward. So we find out. So over here we have to use the substitution to show that to show that this is equals to this. So let us do that. So substitution is u equals to root x. So we simply make x the subject, so x equals to u square, and then we can find out if we can find out this by that just simply differentiating this. So dx by du is equals to 2u, and then dx is equals to 2u by du. So that's what we got here, and then we simply substitute everything. So we substitute the root x by u, so this is this, so and then the dx by this, and then rearranging we get this. So that's it. So hence use hence using integration by parts, find the exact value of this. So over here we use this version to, and then we use integration by parts. So over here the integration by parts formula, so we get this, and then when we integrate this we get cos u. So yeah, and then we use the limits. So the limits are x equals to 0 means u equals to 0, and using this x we get using the previous formula we just showed over here, if we have x equals to this, then we do simply root x to get u. So that's what we do, we root this x, we root this value to get the u value. So these are our limits. So we place the limits now. So over here it goes from 0 to pi by 2, and then when we calculate this we get the pi minus 2 part. So over here we need to find the region R bounded by the curve y equals to sine 2x, the x-axis and the lines x equals to 0 and x equals to pi square. So the x-axis and these two lines, so these are the two limits. So find the exact value of the solid form when R is rotated at 360 above the x-axis. So the way we do this is that rotate out the 360 above the x-axis, right? So this is a circle, so that's pi r square. Okay, so and then we integrate the r over a certain line, so from so over the limits, so which are 0 and pi square. So that's exactly what we do here. We have pi, so that pi, and then r square is the y, this part, right? So this is the, so if you have a graph, so this part with the radius, right? So this is the r. So we have the sine, so we just took the point to this and squared it, and then we multiply and then we were hinted out to use this identity, so that's what we do simply. So we convert it to this, and then we integrate. So over here this is integration just simply x, and this part we have integrated this part before. So using the previous results We use the previous results, but then notice that limits are different this time. So we don't use this result totally. We actually just use the breakdown. So we use this over here before we apply the limit. So this part just, so we put this part here, and then we subtract, and finally we get this. So this question, very, you see, it's not logically, it's not complicated, but it's very tedious. That's it. Okay, thank you. Good luck for your exams tomorrow.